All right, today we are diving deep into a really fundamental shift in AI. We're talking about moving past that old era of just brute forcing pre-training and stepping into the age of what's being called inference-time scaling.
You know, this quote just perfectly captures the moment we're in. The crazy gains we saw from pre-training started to slow down, but that didn't mean progress was over. No way. It just meant that all that heavy lifting, all that computational complexity was moving from the training phase directly to the inference phase.
So what we're really digging into today is the architecture behind this. We're looking at how models like O1 and DeepSeek-R1 are using an internal chain of thought process and reinforcement learning to actually think before they spit out an answer. It's a huge leap. People are even calling it System 2 cognition for neural nets.
Okay, here's our game plan. First, we'll talk about why pre-training hit a wall, because that's what forced this whole new idea. Then we'll get into this System 2 cognition, look under the hood at the hidden scratch pad that makes it all possible, see how reinforcement learning is used to train it, and finally, try to figure out what this new kind of AI cognition really means for all of us.
So, let's start with Section 1, the plateau of pre-training.
You really have to get this part to understand why the shift to inference was so necessary. I mean, for years, the rule was simple. Bigger models, more data, better results. But then, that started to change. The scaling laws that basically defined an era began to show some serious diminishing returns. The gains you'd get just weren't worth the insane compute cost anymore. Something had to give. And that brings us to Section 2, this new paradigm. That plateau we just talked about, it led directly to the rise of System 2 cognition, which is a whole new way of thinking. It basically shifts the computational burden from that one-time training process to every single time you ask the model a question.
And this table just lays it out so clearly. A standard LLM is all about System 1 thinking. It's fast, it's a gut reaction, just auto-regressively guessing the next most likely token. But System 2? That's a whole different beast. It's deliberative. It's about making a plan, spotting when things go wrong, and actually correcting its own reasoning on the fly.
So how in the world is this deliberation actually built? Well, that takes us to Section 3, where we pop the hood. The absolute core of this whole thing is something called the hidden scratch pad. Think of it like an internal workspace where the model does all its rough drafts.
And here's the crucial idea. The model is generating a whole bunch of these thinking tokens that you, the user, never even see. It's basically having an internal monologue, a private chain of thought where it can hash things out and refine its logic before it ever commits to giving you an answer. You can almost picture it, right? The model starts down one path, maybe writing some code, but then, whoops, it hits a snag and realizes, hey, this isn't going to work. Now, instead of just spitting out that error, it backtracks, all internally, on that hidden scratch pad. It tries a totally different approach, and only when its internal logic checks out does it actually generate the final output for you.
Now for Section 4, the training method. Because, let's be real, a model that can self-correct like this doesn't just happen by accident. It takes a completely different way of training compared to what we're used to.
And this is a massive paradigm shift in training. We're moving away from just teaching a model to mimic patterns in human language, and instead, we're teaching it to achieve a very specific goal, produce a verifiably correct answer through a logical process.
The reinforcement learning setup here is super strict. The model only gets a reward if the final answer is perfectly, verifiably correct. There's no partial credit for trying, so over thousands and thousands of attempts, the model gets better and better at building these internal roadmaps that consistently lead to the right answer. It's literally being trained to reason, not just to talk.
So, what does this all add up to? What's the future of AI look like with this tech? Well, that brings us to our final section, a whole new type of AI cognition. And honestly, this is the key takeaway. We are watching models evolve from being incredibly sophisticated pattern matchers to systems that can actively verify their own reasoning. The ability to self-correct based on internal logic, not just on whether something sounds right, is a monumental step forward. It's a game changer. And that leaves us with this final thought to chew on. As these systems get better and better at creating and then validating their own internal logic, that line we've always drawn between just complex calculation and what we'd call genuine reasoning, well, that line starts to get really, really blurry. It's a huge question, and it's one that's going to define the entire next chapter of AI research.